Okay, so another thing we're going to do with polynomials is we're going to look at graphs and try to write the equations of the polynomials from the graph. And it's going to rely on the fact that we know things about zeros and multiplicities. So we're going to have to use a lot of that information about zeros and multiplicities. So one thing I want you to remember is that if r is a 0, then x minus r is a factor. And that's what this sort of equation comes from. If a polynomial of lowest degree p has horizontal intercepts or x-intercepts at all of these places, then I can write the polynomial as x minus an x-intercept to some power, x minus another x-intercept to some power, where the powers we're going to determine from the multiplicities, okay? So how do we do this? Given a graph, you can write the equation by finding the x-intercepts, looking at the behavior to determine the multiplicity. Remember, that means if it's crossing, it's odd. If it's bouncing, it's even. And then we're going to find some sort of factor in the front, like a leading coefficient. So here's a polynomial. Let's try to write the equation. What I see is that there are 3 x-intercepts. X equals -3, x equals 2, and x equals 5. At -3, it crosses. At 2, it bounces. And at 5, it crosses. That means that this guy has an odd multiplicity. We'll say 1. This guy has even multiplicity. Let's say 2. And this guy has odd multiplicity, 1. So we're always just going to pick the lowest multiplicities we can. Okay, if it's x equals -3, then x plus 3 is my factor. It needs an exponent of 1 because it had multiplicity 1. If it's x equals 2, then x minus 2 is my factor. It has multiplicity 2, so we're going to give it an exponent of 2. If it's x equals 5, then x minus 5 is a factor. We're going to give it a multiplicity 1. The only thing we don't know is there could be some coefficient in the front here, okay? So what I'm going to do is I'm going to use this the y-intercept to find that coefficient. This point right here is 0, -2. That means when x is 0, y is -2. So -2 is a times 0 plus 3, 0 minus 2 squared, 0 minus 5. So -2 is a times 3 times 4 times 5 is 60. So a is going to be -2 over 60. So then my equation looks like -2 over 60 times x plus 3 times x minus 2 squared times x minus 5. Let's try one more time. So in this example, again, I see that there are 3 roots, x equals -1, x equals 2, and x equals 4. At -1, it's bouncing. At 2, it crosses, but it kind of gets flat, right? And at 4, it crosses. So what we have to do is we have to deal with the fact that at 2 and 4, it's doing something different. Okay, if it bounces, I'm going to give it multiplicity 2. If it crosses, I need to give it an odd multiplicity. At 4, it's crossing like a line, so I'm going to give it a multiplicity 1. At 2, because it crosses but it gets kind of flat there, I'm going to give it a multiplicity 3. If it crossed like that, I could give it a multiplicity 1. But because it gets flat, I'm going to give it multiplicity 3. So that means my equation looks like some number, which we don't know yet. X plus 1 is going to get a power of 2 since it's multiplicity 2. X minus 2, power of 3, and x minus 4, power of 1. To find that a, I'm going to use that y-intercept again. This is the point 0, -4. So -4 is a times 0 plus 1 squared, 0 minus 2 cubed, 0 minus 4 to the 1. So -4 is a times, so you just put this in your calculator, 1 squared, -2 cubed, -4 makes positive 32. So divide. A is -4 over 32. If you want to simplify, you can. -1/8. So the equation of this polynomial is -1/8 x plus 1 squared times x minus 2 cubed times x minus 4. If you put that in your graphing calculator, the picture should look a lot like the picture they gave you there.